Good evening, dear students. Welcome back. So we were discussing the chapter redox reactions. Yes. So what are redox reactions? Yes, students, what are redox reactions? Yes. So redox reactions are reactions where oxidation and reduction takes place simultaneously. Right. So these are redox reactions. Okay. So in the previous classes, okay, so what all we have discussed in our previous classes, students? So we have studied about just a second. Okay. So we have seen the different definitions. We have seen the different definitions involving what is oxidation, what is reduction in terms of oxygen, hydrogen, then electronegative element, electropositive element in terms of electrons and in terms of oxidation number. Okay. So these were the different, what you say, definitions which we have discussed in our previous class. So next, then we have seen what is oxidation number. Okay, then we had seen what is oxidation number. Then what are the rules? Okay, we had seen what are the rules for calculating your oxidation number. Okay, so these were all the rules which we have studied, and based on the rules, we have solved these compounds. Okay, so these compounds. So one, then this one, and this particular compound, right? So this things we had covered in the previous class. So today what we are going to discuss. Okay, so today we are going to discuss about what are redox titration. Okay, we are going to discuss about what are redox titration. Fine. So what are redox titration, students? What are redox titration? Yes, did you study about redox titrations? Okay, so redox titrations. Just a second. Yes. Okay. So what are redox titration? Okay. So here you take two solutions. Okay, A and B solutions. So what will be there? So two solutions will be there. One will be a reducing solution. Okay, reducing solution. Another will be a oxidation solution. Okay. So one will undergo oxidation. Another will undergo reduction. Okay. So two solutions will be there. So out of two solution, one solutions will be known. Okay, whose strength will be known, whose concentration will be known. Okay, just a second. So we were discussing about redox titration. Okay, so in redox titration, two solutions will be there. One will be a oxidant, another will be a reductant. Okay, so a solution will go oxidation, another solution will go reduction. Okay, two solutions will be there. Now in this two solutions, okay, so one of the solution their concentration will be known. Okay, and another solution whose we will be not knowing the concentration. Okay, so it is a unknown solution. So what we are going to do by doing redox titration, we are going to find out the concentration or the strength of the solution. Okay, by titrating against the known solution. Okay, by using the indicator. By using a indicator. So this is redox titration. So what are redox titration? So titration you have studied in the first year, right? You are studied about titration. You are doing now acid base titration, right? So you might have done acid-base titration. Now in acid-base titration, so okay, one will be oxalic acid, right? So you have done. So now what you have known solution, another will be a unknown solution. By taking the known solution against the unknown, you are going to do the titration and you are going to find the strength of the unknown. So this is the rule. Same way in redox titration, two solutions will be there. One will be a unknown solution, another will be a known solution. Okay. So unknowns, so one will be oxidant, one will be a reductant. Okay. So we are going to find the strength of the unknown solution. Okay. So this is the rule. So now here, so okay, so what we are doing in redox system, so the titration method can be adopted, okay, to determine the strength of the reactant or the oxidant using the redox sensitive indicator. So we are making use of redox sensitive indicator. So the first one is KMNO4 titration. First one is what? KMNO4 titration. First one is KMNO4 titration, students. Just a second now. Can you hear me now? Yes. Can you hear me? Yes. Okay. So KMNO4 titration. So in KMNO4 titration, what is happening? So KMNO4 titration, this is taking place in acidic medium. Okay. This KMNO4 titration, it is taking place in acidic medium. Acidic medium andre, means what? We are taking a what? Acid medium means what? H plus ions will be present. Okay. Now, which is the indicator we are making use of? We are making use of KMNO4. Okay. KMNO4 is a self indicator. Okay. KMNO4 is what? KMNO4 is a self indicator, students. KMNO4 is a self-indicator, students. Okay. So, what we are doing, we are making use of KMNO4. We are making use of KMNO4. Okay, in the acidic medium. So, KMNO4 self-indicator means what? Self-indicator means, yes, students, what is the use of self-indicator? So self-indicator KMNO4, it has a purple color. Okay, it has a purple color. So what will happen? So we are not making use of any other indicator. So this KMNO4 itself acts as a indicator. So it is called as self-indicator. So equivalent mass of KMNO4, if we calculate, you have to, how we will calculate? Molecular mass divided by 5. Okay, so it is 31.6. So this is the first titration method of KMNO4. Okay. Next is by using K2Cr2O7 titrations. Okay, that is potassium dichromate. Okay, potassium dichromate solution. So using potassium dichromate solution also you can make use of titration. You can do the titrations. Okay. So first one is which indicator you can make use of? You make use of diphenylamine. You okay, you can make use of diphenylamine. So which indicator you make use of? You can make use of diphenylamine. Okay, diphenylamine indicator can be used. So what is the equivalent mass of this particular indicator? It is of K2Cr2O7, it is 49. Okay, it is 49. So 49 is the in yes. So now we'll solve some questions. So these were the two titrations. Okay, these are the two titrations. Can you hear me, students? Hello. Which of the following process, okay, which of the following process take place in oxidation process? Oxidation process. A, addition of oxygen. B, addition of hydrogen. C, removal of oxygen. And D, addition of chlorine. Yes, students, which of the following process takes place in oxidation method? Yes. So what is oxidation in terms of oxygen when we are talking upon? It is addition of oxygen. Okay. So yes, Sri Varuni has answered it as option number A. It is correct. Yes. So option number A is the right answer. Fine. Okay. So moving forward, next question. Given reaction. So this is a given reaction. Okay, you can see this given reaction. So the above reaction, given reaction is oxidation. Okay, reaction. Why this given reaction is oxidation reaction? Due to what is the reason why the above reaction is oxidation? Oxidation reaction. A, removal of hydrogen from H2O2. B, additional of electropositive potassium to H2O2. C, removal of electropositive element potassium from potassium ferrocyanide, and D, all of the above are the correct reasons. Yes, what is the reason? Yes, students. So just see the above reaction. Okay. From the above reaction, you have to tell whether so what type of oxidation reaction, what is the reason for the above reaction to undergo oxidation? Okay. So there are four reasons. So you have to tell. Okay. Okay. Sri Varuni has answered it as A. What about other students? For K, for every, so you have to see the above reaction and you have to tell what it is addition of the above particular reaction. Okay. So next question. In the reaction given below, identify the species undergoing redox reaction. So which is the so in the below reaction you have to tell which is the reaction. Okay, you have to identify the species which is undergoing redox reaction. What is okay? So which is undergoing oxidation, which is undergoing reduction that you have to tell. Yes. Yes, students. In the above reaction, identify the species which is undergoing redox reactions. Na, okay. See here, 2Na is there. What will be when you have a free elemental state of the this when you have a free elemental what you say? So when you have a free elemental sodium, what will be this? This it will be zero. Okay, here also this is zero. Okay, because it is a diatomic molecule. So here also it is zero. Now here this is what in hydrides when you have a hydride, it will be -1 and this will be +1. So what is happening? So from 0, it is undergoing +1 and from oxidized and hydrogen is undergoing reduction. It is number D. It is both B and C. Fine. Okay. The loss of electron is termed as. So what is loss of electron termed as? A, oxidation, B, reduction, C, combustion, and D, neutralization, students. Yes. What is, okay. The loss of electron is termed as, yes, it is termed as oxidation. Good. Okay. So the loss of electron, it is termed as oxidation. Good. Okay. And what is gain of electron? Gain of electron is reduction. Fine. Good. In the following reaction. So this is a following reaction, which is the species which is being oxidized. Okay. So this is the following reaction, that is Fe plus 3 plus 2, 2 iodide. Okay. I minus giving you I2 plus 2 Fe plus 2. Yes. So here this is 0. This is 0. This is -1. Okay. So this is decrease in oxidation number. So this is reduction. And this is oxidation. Okay. So increase in oxidation number is oxidation. Yes. So which is species is undergoing oxidized? Oxidized means there should be loss of electron. Yes. Which is undergoing loss of electron, students? Okay. Yes, others. What is answer? Which is undergoing oxidation, which is undergoing reduction? We have discussed the what we have discussed, which is what is oxidation, what is reduction. Yes. So you have to apply the definitions here and you have to tell, okay, which is undergoing oxidized and which is undergoing reduced. Okay. Oxidized means what? Okay. Now oxidizing agent, what oxidizing agent does? Oxidizing agent oxidizes other and itself undergoes reduction. Okay. Oxidizing agents, what they do? It oxidizes other and itself undergoes reduction. What reducing agents do? Reducing agent reduces other. Okay, reduces other means there will be gain of electron. Okay, and it undergoes itself undergoes oxidation. Okay, now oxidizing agent oxidizes other and it's the reduction. So which is getting oxidized itself? Yes, oxidizing means there will be loss of electron. Okay, which is undergoing loss of electron, it is I. Yes, it is I minus. Yes, it is I minus. So option number, okay, option number B is the correct answer. Good. Okay. Next question. You have to apply the definition. So, um, what you say? You have to understand the definitions and you have to apply them. Okay. After studying the definitions, you have to apply it. Okay. Which of the following reactions depicts the property of SO2? Which of the following reactions depicts the oxidizing property of SO2? SO2 plus H2O giving you H2SO3. B, H2S plus SO2 giving you S plus 2H2O. 3, chlorine plus SO2 giving you SO2Cl2. And D, MnO4 minus SO2 plus 2H2O giving you 5SO4 minus 2 plus 2Mn plus 2 plus 4H plus. Yes. Yes. So which of the following will depict the oxidizing property of SO2? Yes, students, oxidizing property means itself undergoes oxidation 2 minutes, students. I'll just share the screen. Okay. So can you see the screen now? Okay. So there was some network issue. Okay. Yes, so we were discussing which of the following reaction depicts the oxidizing property of SO2. What is oxidizing? Okay, oxidizing means what? It oxidizes other and itself undergoes reduction. So oxidizes means there will be loss of electrons. So from your plus 2, it undergoes 0. Okay. So SO2, what is SO2 doing in option number B? Okay, in what is SO2 doing in option number B when we check? Okay, so SO2 is oxidizing H2S and S. Okay, so it is oxidizing H2S and S. This H2S is oxidized. So since oxidation number of S changes from -2, so in this, okay, when we have seen the oxidation number, so here it is -2. So this is -2. Okay, and in H2S it is 2s it is 0. Okay, so what is happening here? From -2, the oxidation number of S changes from -2 to 0. Okay, so there is, and okay, so this is A. B is the correct answer. Now in A, what you can see in A, there is no change in oxidation number of any of the element. Okay, if you see the oxidation number, so this is plus 2. Okay, here you can see this is plus 2. Okay, and this is -6, and this is plus 4, 5, 6, plus 4. Okay, so this -2, and this is plus 2. This is -4. Fine. So -4, this is also plus 4. Fine. So this is like this. So oxidation state, you can see in the first example, it is plus 4 itself. Sulfur is plus 4, and in product also it is plus 4. So there is no change in oxidation. So this is wrong. Then when we are checking C, okay, in C also, C and D, what is, it is acting as a reducing agent. So in C and D, SO2 is acting as a reducing agent. Okay. So this is also wrong. So option number B is the right answer. I hope this is clear. Okay, so we'll go for the next one. Which of the following statement is not correct? A, potassium permanganate is a powerful oxidizing substance. B, potassium permanganate is a weaker oxidizing agent than potassium dichromate. And C, potassium permanganate is a stronger oxidizing agent than potassium dichromate. D, potassium dichromate oxidizes a secondary alcohol into ketone. Yes, students. Which of the following statement is not correct? Yes. Which of the following statement is not correct? So these are the four options which we have seen. So when you see that, okay, this is about potassium permanganate. So when we are talking about potassium permanganate, so potassium permanganate is a good oxidizing agent. You can say it is a strong oxidizing agent. Okay. So what does potassium permanganate? Okay, it is KMnO4. You know KMnO4. So what is the color of KMnO4? It is a purple in color. Okay, and it is a powerful or it is a strong oxidizing agent. Okay, as compared to potassium dichromate, okay, it is potassium permanganate is more stronger than potassium dichromate. So this is also correct. Then potassium dichromate, it oxidizes alcohol into ketone. So this is also correct. The statement which is wrong, it is potassium permanganate is a weaker oxidizing agent than potassium dichromate. Okay, because KMnO4 is more oxidizing agent than the K2Cr2O7. Okay, because when we compare the standard hydrogen electron. So how we can say that potassium permanganate is a stronger oxidizing agent? Okay, because we need to consider the we will be considering here the standard hydrogen electrodes. Okay, standard electrode potential. Okay, we are going to compare the standard electrode potential values. Okay, so potassium permanganate, it is plus 1.52 volts, the standard electrode potential, and that of potassium dichromate is plus 1.33 volts. Okay, both in the acidic medium. So when you are comparing it, whose standard this is more, it is more of potassium permanganate, right? So what do you mean by standard electrode potential? Standard hydrogen potential. Okay, it is a one way of measuring how easily a substance losing electrons. Okay, so it is a way of measuring how easily a substance it loses electron. So if the values are negative, okay, if the values electron potential values are more negative, then that means it releases more electrons. Okay, readily it can release more electrons. And if you have positive values, means it releases electrons less. Okay, they releases electron less. So option number B is the wrong statement. Okay, option number B is the wrong statement. Okay, moving further, the reaction of KMnO4 and HCl results in A. Oxidation of Mn in KMnO4 and production of Cl2. B. Reduction of Mn in KMnO4 and production of H2. C. Oxidation of Mn in KMnO4 and production of H2. D. Reduction of Mn in KMnO4 and production of Cl2. Yes, students, what is the reaction of KMnO4 and HCl? What it results into? So I'll write the reaction. Okay, I'll write the reaction. So KMnO4 plus HCl. Okay, giving you KCl plus MnCl2 plus H2O plus Cl2. Okay, when we are balancing it, so this becomes 216. This is 2 KCl, 2 MnO2, 8 H2O, and 5 H2O molecule. Yes. Okay. So what is happening to the oxidation number? Just check. So the reaction. So from plus, so Mn is plus 7. Okay. Then it is going to plus 2. Mn plus 2. So from plus 7, it goes to plus 2. So what is happening? There is a what? Decrease in oxidation number, means it is reduction. Okay. And KCl. So Mn oxidation. So what is happening? The oxidation number of Mn, okay, is changing from plus 7 to plus 2. Okay, and chlorine gas, when you are talking about chlorine, this is 0 and this is minus 1. So from minus 1 to 0. So there is what? Increase in oxidation number. So it is oxidation. Okay, so chlorine gas is formed as a product. So which is the correct answer? D. Yes. Answer is D. Yes. Sri Varuni has answered it right. It is D. Reduction of Mn in KMnO4 and production of Cl2. Okay. So this is the correct answer. Okay. Next question. One of the following has both positive and negative oxidation states. Yes. Which of the following will have both positive as well as negative oxidation state? Fluorine is -1. Okay. Chlorine is -1. Helium is 0. Then sodium is +1. Yes. Yes. Cl. It is B, Cl. Okay. So chlorine can have -1 also. Chlorine can have +1 also. Okay. We have seen this in the what in our rules. Okay. So sometimes, so both positive as well as negative oxidation state. So it is in chlorine. Fine. So we'll go for the next one. What is the oxidation number of elements in the free or in the uncombined state? Yes, A +1, B 0, C +2, and D -1. So what is the oxidation state? Oxidation number of elements in the free or combined state. What do you mean by free when sodium is there? Or in combined state like Fe2, O2. Okay. What is the, yes, what is the oxidation number in such states? Sodium will be, yes, what will be the oxidation state, student? It is, yes, it is option number B. It will be 0. Okay, in the free state. So this is a free state. So in the free state or in the what uncombined state. Okay, that is in the what you say diatomic state. So okay, so that time it will be 0. The oxidation number will be 0. Oxidation number of H in sodium hydride, calcium hydride, and lithium hydride respectively is. Okay, so we'll find out sodium hydride, calcium hydride, and lithium hydride. So, okay, so lithium, sodium, these are what? These are what these are? These are alkali metals. These are alkali metals, right? What is the oxidation state of alkali metals? It will be +1. So alkali metals are +1. So lithium is +1. Sodium is +1. Now, if this is +1, so these are what? These are called as metal hydrides. These are called as what? These are called as metal hydride. This is also example of metal hydrides. Okay. Metal hydride. So these are the examples of metal hydride. So whenever you have metal hydrides, hydrogen will be in -1 oxidation state. Now you have calcium hydride also, CaH2. So calcium, okay, calcium is a alkaline earth metal. Calcium is a alkaline earth metal. Calcium is a alkaline earth metal. So calcium oxidation state is +2. So hydride will be -2. So each hydrogen again here will be -1. Okay. Yes, good. Okay. So what is the oxidation state? In sodium hydride is -1. This is -1. And lithium hydride is -1. Okay. So option number, which is correct? It is option number D. Yes. Option number D. Yes, good. Okay. So whenever you have metal hydrides, okay, whenever you have metal hydrides, so that time what will happen? Oxidation state will be of hydrogen will be -1. Remember that. Okay. The brown ring complex is formulated as Fe, okay, H2O5NOSO4. The oxidation number of iron is, what is the oxidation number here of iron? So I'll write the complex here, Fe, H2O5, NOSO4. Yes, students? What is the oxidation number of Fe? So Fe, I don't know the oxidation state, so I'll keep it as X. Okay, plus number of water molecules are 5. Each water molecule oxidation state is 0. Then plus nitronium ion is plus 1. Okay, then into, okay, then into sulfate is 1 into minus 2. Okay, equals to 0. Solve this. X, 5 zeros are 0. Okay, plus 1 into minus 2. X equals to plus 1. So if we shift there, it will be 0, 1. So it is plus 1. So option number A. Everybody got it? Yes. It is option number A. Okay, so Fe, the oxidation state of Fe in this brown ring complex is plus 1. Okay, I hope you are getting it. So please, you have to understand how to find the oxidation states. Fine. Next is, in which of the following reactions there is no change in oxidation state? Yes, in which of the following reaction there is no change in oxidation state, students? KClO3 giving you KClO4 plus KCl, BSO2 plus 2H2S, okay, giving you 2H2O plus 3S. Then BaO2 plus H2SO4 giving you BaSO4 plus H2O2, and D BaO plus O2 giving you BaO2. So KCl is plus 1, this is 6. So this is plus 5. Okay. This is plus 2, 4, 8 plus 1. So this will be plus 7. Okay. So minus 1 plus 1. Then SO2 minus 4 plus 4. This is plus 2 minus 2. Minus 2 plus 2. This is 0. Barium minus 4 plus 4. Minus 8 plus 2 plus 6. SO4 minus 8. Yes. Yes, students, see now. 0 minus 4 plus 4 minus 2 plus 2. So what is happening here? There is increase in oxidation. So it is undergoing oxidation. Here it is Ba plus 4 is remaining the same. Here you can say yes, so from plus 4, okay, it is undergoing what? 0. So here it is showing reduction. Then here, okay, from plus 5 it is undergoing, so here it is oxidation, okay, increase in oxidation number. So these are all examples of A, B and D, okay, are examples of redox reaction. Okay, in redox reaction, one will undergo increase in oxidation number, another will undergo decrease in oxidation number. But here when you are seeing this option number C, okay, barium is having plus 4 only, barium is having plus 4 only, hydrogen having plus 2, here also hydrogen is having plus 2. Okay, so what it is, there is no change. So this is the example of this reaction is example of double displacement reaction. Okay, it is an example of double displacement reaction. Okay, so all the atoms here are present in the same oxidation state. Okay, in the reactant as well as in the product. So option number C. Fine. Next question, the oxidation states of sulfur in the anions SO3 minus 2, then S2O4 2 minus and S2O6 2 minus follows the order. Yes, what is the oxidation states of these? So I'll show you how to find out the oxidation number. So X, okay. Then plus 3 into minus 2 equals to minus 2. So this is x minus 3 to the 6 equals to minus 2. X minus 2 plus 6 equals to 4. So here the oxidation state of sulfur is plus 4 in the first. Now, second one, S2O4 minus 2. Okay, so x 2x plus 4 into minus 2 equals to minus 2. 2x minus 8 equals to minus 2. 2x equals to minus 2 plus 8. 2x is equals to 6. X is equals to 3. Okay, fine. Next one more. S2O6 minus 2. 2x plus 6 into minus 2 equals to minus 2. 2x minus 12 equals to minus 2. 2x equals to minus, 2 plus 12 equals to 10. X equals to, so 2 by 2 is equals to 5. 2 5s are 10. Yes. So what is the oxidation state of sulfur in the anions? What will be the following order? Yes, so S2O4 2 minus is less than SO3 2 minus. SO3 2 minus is less than S2O6 2 minus. Okay, so S2O4, then comes SO3 minus, and then comes S2O6. So it is option number B. Yes. Did you get the same? Option number B, students? Yes, good. It is option number B. I hope you are getting the things. Okay. So what they have asked, they have given 3 anions of sulfur atoms. Okay. And you have to find the oxidation state. Now, after finding the oxidation states of sulfur in these anion form, then you have to arrange it in the increasing order of their oxidation states. Okay. Like this. Fine. Next, okay. So these were the things about the, okay, so we have solved many more examples. Okay. So types of redox reactions. So this will be dealing in the next class. So any doubts in any of the previous slides? Yes, students, any doubts regarding the oxidation number? Okay, fine. So types of redox reactions. So I'll be dealing this in the next coming week. Okay, students. So if you have any doubts, you can ask me in the chat box. So in the next class, we are going to discuss about the types of redox reactions and few MCQs based on that. Okay. Okay. So if there are no doubts, so I shall end the session here. Yes, students. So we'll be meeting in the next week. Okay. Completing this further part of redox reaction, we'll be discussing about the types of redox reactions, some examples on these types of redox reactions, and we'll be solving some MCQs. Okay. So I'll end the session here. I hope. Okay, you have no doubts. So we'll meet in the next session. Thank you.